In this session, we will discuss about real-time embedded systems. So, what's an embedded system? Means a software that is embedded to a hardware to do a particular dedicated function. For example, in your washing machine, to perform a particular P1 or P2, some functions are there. So, to perform a particular function, we are writing a software that is embedded to the hardware. That's why we call it as embedded systems. The embedded system is a small, maybe independent, or maybe it is used in a large combination. For example, simple washing machine you are using one program. In car also you have multiple accessories. For example, your ABS system, anti-braking system, you have temperature monitoring system. So each and every system we have separate embedded programs for incorporating. So embedded systems, the processor is the heart of the embedded systems. In the processor only we have microprocessor or maybe microcontroller or DSP, different process is there. So we have to program in that processor, right? So all these devices are programmable. The common thing in all these DSP or microprocessor or microcontroller is all are programmed according to our requirement. We are going to program the processors. The software part is the important part of your embedded systems, where we are going to use C or C++ or Java, any program we are going to use. Either even assembly language program also you can use. The application level program, for example, Java or Visual Basic you can use. So major components of embedded systems are your hardware, your application software, and RTOS systems. And this block diagram shows the major components of your embedded systems: hardware, RTOS, and is connected to the application software. Okay. So what is RTOS? RTOS is nothing but real-time operating system. So it is a special purpose operating system. It is used in the computers that has strict time constraints for any job to be performed. It is called RTOS. Right. And what is called compilers and decompilers. So compilers used to convert the source code from a high-level programming language, maybe a C or C++, to a low-level programming languages. So it converts the code written in that C to a assembly language. For example, a tool used to translate low-level language to high-level language is called decompiler. Just opposite to this called decompiler or and assembler. So it is a part of the embedded system tool. So it is used for translating the computer instruction to in assembly language to a machine understandable code to perform its basic operations. Next, so this shows that 8089 C51 is the microcontroller used in your real-time operating systems, real-time embedded systems. 8089 C51. It contains some 40 pins. Out of that, your P0, this is nothing but 4 ports are there. P0, P1, P2 and P3, they are used as both input and output. You can use these ports, you can use. So total of 40 pins. Right. These are the software used in your real-time embedded systems. We can use any software. So here we are using either a Proteus, it uses application software. Similarly, a Keil is another software used for our real-time embedded systems. Arduino you can use it for the real-time embedded systems. Okay. Now I will explain a program. How to run a program like that I will explain. For example, so how to execute a program in your real-time operating system? First you start with your coding part for Keil. Open your Keil. Right. In this case, you click your project. In the new microvision project you take, you can save it anywhere. But I can save it, for example, I am showing in a D drive. Okay. I have given some name. Maybe I am giving as RTS, I am giving a name. I am giving a folder. Right. So in this folder, I am going to save. I am going to give a file name also. I am going to give a file name also. For example, I am giving a traffic light. So when I am clicking this, it asks select the device for target. So for that I have to select the device. Here I am explaining the right. ATMEL. I'm clicking this one. Here I go to select AT89C51. Okay. Here they are asking copy startup to the project folder and add file to the project. Here I can select O. Okay. So now your target is created. I go to click on the target. Here I go to click source group. Right. Source group I go to add the file and convert into a C file and then convert into hexapath file. So first option I go to go for file. Then I am clicking your new. Right. A new text file is open. Here I go to write down the code. So code I have already written. So I'm going to select this code now. So here I am going to paste the code. Here I am going to paste the code. Then after pasting the code, I have to save this file. I have to save this file where I am going to start the project with RTS. The same file I am going to save, but I am giving the name with .c as a C file. I am going to save with the .c options. So now the file is given saved. Okay. So now I have to add this project. Now I am giving a file with the C. I have to add. So I add existing files to the source group one. So here the given file topic is there. I have to select this file. I have to add, close. Right. So now you can see if I am clicking this one source group, the file is getting added. Next I have to convert this C file into a hexadecimal file. So for the purpose I am clicking this target. I have to give your options for target one. Here I have to give 24 megahertz. This clock speed is given. I have to convert it to speed. Clock speed converted to 11.0592. And here the output, I have to remove tick here, and I have to select create hex file. I have to give OK. So now the file is ready. Now click on your target. Right click. Here I have this file, build target. Either you can click F7 or build target I have to do. So here I am getting some error here. Right. The error you can see in undefined array. I have to find out where is the error. By double clicking it, I can see here where the file is error is occurring. Here there is no space between the variable and the declaration. So I have to give int again. So now I have to select, like, again I am clicking target, click on that, I am getting build target. So now the target is created, traffic 0 zeros. So now the programming part is over. To check this program part and to check, I have to go for another software called as Proteus software. So for that I have to open your Proteus. Here the Proteus software, open front-end software. Here in the Proteus, first I have to click your new project. Okay. Here I can select the same folder. For example, browse. Here I have in the D drive, I am created a name called RTS. I have to select that folder. Then I have to press simply next. Here the option is default. Keep as it is. Proceed to next. Here do not create a PCB layout. Click next. No firmware project. Click again next. Here the schematic is selected. You could finish. So now this front end is selected. Now I have to put this microcontroller on the traffic light signal. So for that, what I have to do means here I have to click the symbol P. Here by clicking this, I have to put the keyword as 89 C51. Right. So I have to give 89 C51. Apart from that, you have so many options is there, but you have to select only this one. So select this one. Okay. Now the component is selected. Just by clicking here, the component is pasted here. Okay. You can zoom also. Now I have to put another traffic light control. For that I have to again press P. Here I have to search for the traffic light signal. Traffic light. If I type like means it will display traffic lights library is active. So I have to select traffic light is selected. I have to proceed here. Okay. So now I have to connect the port P2 port because I have written program P2 to connect your traffic library. So connect the first pin of your P2 port to your first LED light. Traffic light first one. Second one the pin number 22. Pin number 22. I am going to connect to second one. And pin number 3 I am going to connect to the third one. Right. So now the microcontroller as well as your traffic light is inserted. I have to connect this front end to your program part. So for that simply I am double clicking this one. Okay, I have double click this one. This window is open. In this window the frequency is given as 12 megahertz. But I have to match with the other frequency. So 11.0592. I have to change the frequency. Similarly, I have to connect this background file. So for that, I have to click on the program file. I can see a hexa file is created in the same folder. I have to select that hexa file and I have to click OK. Now this both the Keil and the Proteus are linked together. I can run this program here. Okay. So here initially the red is on. After a time delay, it has to change to your orange or yellow. Then again after time delays go to your green. So this is the front end software. So now I will explain this program part here now. See here, this is the program part. So what is this program part means? This first command it includes the registry which enhances the your tools which are used in your microcontroller with different ports to make use. S bit means single bit. The port P2 means P2's first pin is 0th bit, second pin is 1 and third pin is 2. They are assigned to the single bit variables. The special purpose registers they are called. They are called red, yellow and I am initializing is P2 of 0 to red, P2 of 1 to yellow. The special purpose registers are assigned to these variables. First I am initiating a delay. When I call the delay function, the argument given is integer time argument. Whatever value I am giving, it will call the delay. Okay. Then when the delay is somewhere here, when this is called argument, if I am passing some value means it initiates just 2 loops just for delaying the blinking of your LED light. Sorry, traffic light. So this inner loop just simply rotates, it's just wastes the time. And the outer loop determines how long the light has to be on. Red light, how much time it has to be on. Like that, how long the light has to be on, that is determined by this time. Okay, now coming with the main program. So here in the main program, initially I am initializing all to 0. So when it is assigned to 0 means there is no light is off, no blinking. Then while 1 means it means infinite loop. We are going to run the loop continuously. That's why I am giving while 1. Initially I am giving red is equal to 1. So I am calling delay is equal to 0. When I am calling delay to 0 means red is on and delay is called. I am passing is integer times equal to 1000. So now it calls off this delay. It is given as 1000. So here that I is given as 1000. I is equal to 0. I less than 1000. So it rotates for 1000 times. Once the loop is completed, again it goes to this point. Again I initiate red to 0. Again I am initiating yellow is equal to 1. So like this loop is continuously going because you are initiating while equal to 1.